Okay, so you will want to take a few notes. Maybe is there somewhere on the back? I can't remember. Not really. Anyways, so make sure you take a few little notes, maybe at the top or find some place. But for the most part, it's pretty straightforward. So we have to understand, like we can create an angle. So couple things to note. This is an angle. It's just a floating angle. So notice this would be. I'm going to call this my initial side. And you don't need to take notes on this. And then I open up, boom, and this is considered my terminal side. So the terminal side is where it's opened up to. This is just an angle I've drawn in just the floating air. Now, we're going to be able to draw angles in standard position. So instead of just drawing it floating, what it means is drawing an angle on the XY coordinate grid. So no different. If it says to you, draw an angle in standard form, you're just drawing an angle on an XY chart. So for example, it's starting here. Here's my initial side. And now I'm going to open it up, boom, and I've just created an angle. So see how it's no different? It's just drawing on an XY chart, everybody. This is called a terminal side. So you will want to know that vocabulary word in case they say we have an angle where the terminal side is at 30 degrees. That just means it's opened up to 30 degrees. Everybody good? Now we usually draw arrows to show which way our angle opened up because there's two types of angles. There's positive angles, which will be going counterclockwise. So here's my clock, guys. A positive angle is created if you go this way and open up your terminal side counterclockwise. So the one I just drew was a positive angle. Everybody understand? Okay, so that would be a positive, for example, whatever degrees I open that up to. And then also there's negative angles. Negative angles is going the other way. It's going clockwise. So if I was to start here with my initial side and open up the angle this way, that would create a negative angle. So going this way around creates a negative angle. This way around is positive. Everybody understand? Okay, awesome. So now another few things to note is this is 0 degrees, and then once you go all the way around the circle, you're back to 0 degrees. That's 360 degrees. Everybody understand? Now halfway up here, this is considered 90 degrees. So each fourth is 90 degrees. So look, if we go up 90, isn't a half circle 180, everybody? So this is 180 degrees. And then if we go down here, that's adding another 90, so that'll be 270 degrees. And if we add another 90, that puts me at 360. So the angles between 0 and 90 will be in quadrant 1. This is considered quadrant 1. Angles between 90 and 180 is in quadrant 2. And they write it like this, sorry, Roman numerals. Quadrant 2, angles between 180 and 270 would be in quadrant 3. And then angles between 270 and 360 would be in quadrant 4. So if we were to go the negative way, then this would be negative 90 degrees. Everybody understand? Negative 180, negative 270, negative 360. Everybody feeling good about this? Pretty easy, right? Cool. So that's what we're going to do first. So we're just going to start. We're going to draw angles. So it says, oh, actually, in this one, we're not drawing angles. It says find the measure of each angle in standard position. So we're going to kind of have to use like our logical thinking skills here, which is pretty easy. So everybody look at number 1. Notice on your number 1, they didn't draw in these like dotted lines saying that's the angle. I want you to draw that in. So this is the angle we're looking for, question mark. So they gave us a hint. They say, so first of all, I want you to notice, we started here and we went around in the positive direction. Everybody understand? So this is a positive angle. Now, if we know that this distance, they give you a hint, from here to here is 60, can anyone think of how we can figure out what the angle is? Yeah, going all the way around would have been 360, right? And there's many ways to do it, guys. You could have done, so anyways, let's keep going with that. So if we take 360 and subtract off 60, that would give me 300 degrees. So this angle measure from here to here was 300 degrees. Everybody understand? So there was a couple ways we could have done that, but that's one of them. Yeah. So what's the angle? 300 degrees. Okay, let's do number 2. Let's use our logical thinking. There's not one right way of doing it. There's multiple right ways. On number 2, it says, what is the angle? So this is the angle we're looking for here. They give us a hint. This from here to here is 60. How can we figure this out? Good. 180? Yes. circle just means we are like it's called center O. So that's just like center O. Like nothing. Like it's just the center of the XY chart. Because technically they'll call it angle O. Does that make sense? So because that's called O. So they say angle O is. Does that help? Good question. Okay, so 180 minus 60 degrees, right, everybody? So that angle right there would be 120 degrees. Okay, let's look at number 3. And once again, you got to look, is it a positive angle or negative? So on number 3, they're drawing this little arrow around, so it's positive because we're going counterclockwise. So this one's easy. We would do 360 minus 45 degrees to figure out what that distance is. So that's 315 degrees. Pretty easy. Any questions? So they might write it as angle O equals 315 degrees. Okay. Let's go to number 4, 6, and 10. It says sketch the angle in standard position. So we're sketching a rough angle, but you're going to be pretty detailed so that I know your angle is 100% correct. You can't just do a rough sketch without giving me some hints here. So the first one we're drawing is, for example, number 4 is 100 degrees. So that's a positive. So what you're going to do is draw in your initial side. Draw in your initial side. Now we're going to open that angle up in the positive direction, and we've got to go to 100 degrees. Isn't this 90 degrees right here? So don't we need to go 10 degrees further? This way. So you're going to go like this. You're going to go, okay, you're going to give me a hint. From there to there is 10 degrees, for example, so that I know you went 90 degrees. And then also, I want to see that you drew not, because look, well, how do I not know that you were trying to do that angle? So I want you to draw in an arrow like this saying I went that way. I drew this angle that way. That's my 100 degrees. So that's the detail I want to see. Let's do number 6. It's negative 45 degrees. So what you need to do is draw in your initial side. Now because it's negative, we're going downwards. And this is negative 90 degrees right here. So won't halfway between be 45 degrees? Good morning. Good morning. So we're going to go and draw halfway down this. And that would be, ding, 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 ding. That's our angle we drew, and that was negative 45 degrees. So you could give me more of a hint. That's pretty straightforward, though. But you could also say this is 45 degrees there. Does that make sense, everybody? Okay, let's do let's do 10. Negative 145. So you would draw in your initial side. Now we're going negative again. So we know that this is negative 90. And isn't this negative 180 degrees? So we need to go somewhere between negative 90 and negative 180, right? Now I need you to be pretty specific, like where are we going here? So how can we maybe figure this out? Yeah, good point. There's many ways of thinking of it. I like it. So, but we have to think about this. If this is 90, then we would go 10 more degrees to be at 100. And then another 45 degrees, right? So that would be kind of more like over here. So we would go ding, 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 ding. That's negative 145 degrees. Now think about it. I could literally take my calculator and I could do 180. I'm just going to use positive. So I'm going to do 180 minus 45. And that's, no, I'm going to do, sorry. 180 minus 145. So how much will be, that's 35 degrees. So guys, from here to here is 35 degrees left before you would get back to 180. Does that make sense, everybody? So some hints here would be nice. Questions on that? Do you see how this adds up to be 180? Okay, that's the detail I want to see. So you're going to do now 1 through 11 on the front, and then you're going to do 1 through 12 on the back page. So start on the front, finish up 1 through 11, then jump to the back page, which is just the back worksheet, which says classwork, and do 1 through 12, go for it. And I can come around and start helping and checking. Okay, we know how to take an angle and draw it in standard position. So this is our initial side, and here's our starting point, our initial side, and then this is our terminal side, the side we open up to. Co-terminal angles will fall in the exact same spot as the original angle. So coterminal angles will end up in this exact same spot, the same terminal side. So think about it, guys. Wouldn't that be going around in a full circle and put me back there in the same spot? Can we go around the circle again and put me back at the same spot? Can I go around again and I'm back at the same spot? Everybody understand? So how do we get a coterminal angle? One that falls in the same spot. What did I do? Added 360. So a coterminal angle will fall in the same spot. We just take that angle and add 360 because that will put us back in that same spot. Couldn't I go this way and be still back in that same spot? Back this way. So I can also subtract 360 and end up back at the same spot. So to find a coterminal angle, you take the angle, theta, and you can add 360 to get a coterminal angle. That'll put you in the same spot. Or you can take your angle theta and subtract 360 because that will give you a coterminal angle. It'll put you in the same spot. Yep, we can add circles however many times we want, and we can subtract circles however many times we want. So let's find some coterminal angles. So for example, guys, negative 100 degrees, add 360. What do we get? Negative 100 degrees plus 360 degrees. 260 degrees. So guys, 260 degrees puts me back at the same spot, right? There's 260. Does everybody understand? 260 degrees puts me at the same spot. We all good? So I could add 360 again to 260. I could add 360 and that would put me back there again. Do you guys get what I'm saying? So I could subtract 360 and that would be negative 400 and negative 400 degrees, right, everybody? Okay, awesome. So we all understand how coterminal angles work. So once again, here's my terminal side. If I wanted to get back there, I could this would be subtract adding 360, right? That's a positive angle. That put me back there. Do you guys get what I'm saying? Yeah. So what's an angle that's coterminal with 60 degrees? Add 360, what do we get? 420. So guys, think about it. If I start at 0 and go around 420 degrees, that puts me in the same spot. Do you all understand? All good? No, it starts from the initial side. The 420 will put us at the same spot. But we just take theta and add 360 to get us there. Does that make sense, everybody? Okay, so that would be considered a positive coterminal angle. A positive coterminal angle. So with this one, a negative coterminal angle would be if we subtract 360. So wouldn't that be negative 360? 100 minus 360 is negative 460, right? So I'd be starting at 0, going around, and then there, that would be negative 460 degrees, would be a negative coterminal angle. Okay, awesome. So here we go. It says find the measure of an angle between 0 and 360. So we're reading the directions. Everybody take it all in. Find the measure of an angle between 0 and 360 coterminal with each given angle. So coterminal means falls in the exact same spot. So we're dealing with negative 100 degrees. They want to know what's an angle that's between 0 and 360 degrees that will fall in the same spot as that. So instead, let's look at the positive angle instead of the negative angle, in other words, right, everybody? So don't we just take negative 100 degrees and add 360, guys? So our coterminal angle that's between 0 and 360 is 260 degrees. So if you draw, my question is, if you draw negative 100 degrees or 260 degrees, won't it fall in the exact same spot? One would just be going positive around 260, boom, and the other would be going negative 100, boom. Everybody get it? Okay, awesome. Let's do this one. Now look, that was the one between 0 and 360, so we would just get a stop. So on 18 it says, find the measure of the angle, coterminal with 482. So let's do that. We would take 482. We want it to be between 0 and 360. So in this one, we're going to subtract 360 to get a little bit smaller of an angle and an angle on this interval. So we get, yep, 122 degrees. So that's the angle between 0 and 360 coterminal. They'll fall in the same spot though. So 660, we're doing 28. If I said to you, find the measure of an angle between 0 and 360 coterminal, so falling in the same spot as this, we could go ahead and, we're going to go down, right? We want to get smaller. So let's subtract 360. And what do we get? We subtract 360 and we get 300 degrees. Very good. Now let's pretend that that was still too large. Let's say that our interval wasn't, or let's say that we were still not in our interval. Couldn't we subtract 360 again? For example, if we had like 1,000 degrees, couldn't we subtract 360, subtract 360, subtract 360, we'll end up still in the right spot. You get what I'm saying? Okay, awesome. Okay, go to 13 on the back page, flip over. So it says, you've got to answer the question correctly depending on what it asks. It says on 13, are the angles coterminal? So coterminal means falls in the same spot. We can find coterminal angles by adding or subtracting 360. So I'm going to start with 95, for example. We don't have to start with 95, but it wants to know, is this coterminal? So aren't we getting very small here? We're getting smaller and smaller, right? It's negative 625. So I'm going to subtract 360. So you would do 95 minus 360. Good. So negative 265, which equals negative 265 degrees. So far, we don't know still. Let's subtract 360 again. Let's go around the circle again in the negative direction. So minus 360, and we get negative 625 degrees. So with that, it was coterminal. Yes. If it would have ended up at negative 630, then they weren't coterminal angles. Okay, awesome. Look at 17. 17 says, find a positive and negative coterminal angle of 250. So 250 degrees, we can find a positive one by adding 360 degrees. And to find a negative coterminal angle, we can take 250 degrees and subtract 360. Just go around the circle the other way. So on 17, our positive coterminal angle is 610 degrees. That would put me in the same spot as 250. And my negative coterminal angle is at negative 110 degrees. Everybody good? Ready to just go for it for a while? Cool. Ready? And do the ones I have assigned up here. Ready, set, go. Okay, so grab your unit circle. Okay, what the unit circle, guys, is we're not going to get into too many great details here. We're just going to kind of go for it and learn how to use it. But everybody, we were just drawing all different angles in this standard position, correct, everyone? Now, what the unit circle is it has just special, obviously there's a lot more angles in here. Like, look, between 0 and 30 degrees, right, is like halfway between. We're going to have all these different angles, right? There's 61, 62, 63, 64, 65. We have all these different degrees in here. The unit circle just has these degrees that have special values. So these are kind of like what I call special degrees. These degrees are actually come from our special right triangles. Notice 30, 60, and then 90. So we have a bunch of right triangles in here if we want to get technical. So these special angles come from special right triangles. So at these angles, guys, there's these special x, y points that we can use to find sine and cosine. So one thing to know is cosine is your x value and sine is your y value. So at 30 degrees, we have an xy point. If I said to you, what's the cosine of 30 degrees? This is a special angle. We can use our unit circle to say the exact value instead of the approximate value. So if I said to you, what's the cosine of 30 degrees? You could type it into your calculator, correct? But I would give you an approximate value only. So that would not be an acceptable answer. Because 30 degrees is a special angle and you can give me an exact value. Cosine of 30 is our x value. It's root 3 over 2. So does everybody kind of understand what I'm saying? You've got to remember that cosine is x, sine is y. So make sure you write that down. These are x, y points. So now we can figure out the sine and cosine very easily of all these values. And you can actually figure out tangent too. This time we're not doing tangent, but I just want to say it. Tangent of theta, we can actually find sine, cosine, and tangent using the unit circle. Of these special angles, tangent would be your y value divided by your x value. So to find tangent at 30 degrees, you would take 1/2 divided by root 3 over 2 and then simplify it. That would be tangent. So that's actually quite easy because that's a lot easier than having to draw a right triangle and figure it out. Does that make sense, everybody? Okay, one thing to note here is this is quadrant 1. Notice that sine and cosine are positive, meaning my xy points, think about this. Oh, I want to say one more thing. The unit circle has a radius of 1. So from here to here is a unit 1. So we draw this around and it's a unit circle with a radius of 1. Notice all of these xy points are positive x, positive y, plotting the point. Does everybody see how it's positive x, positive y to plot the point? So cosine's positive and sine is positive in quadrant 1. Look, all of my xy points, cosine and sine are positive. Cosine's positive and sine is positive. So everybody think about these xy points over here. Won't we be going in the negative direction for x to plot this point? If I was literally just going to plot a point, we all know how to draw a point, right? Wouldn't I go back this amount and then up this amount? So that would be negative x, positive y. Look at my x values. They're all negative, but my y values are all positive. So our points make sense here. Does everybody see how it works? So you would say that in this quadrant, our cosine is positive, which you can see. I mean, our cosine is negative. You see how our x values are negative? But our sine values would be positive. So everybody look over here. If I was literally just drawing, because this is just an xy coordinate grid, if I was to plot this point right here, you're going in the negative x and then down y as well. So in this quadrant, notice all of my xy points are negative, negative. Well, does that make sense? Negative, negative to plot the point. Negative, 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 negative. So my cosine and sine would both be negative here. Sine negative, sine is negative. And then over here, if I was going to plot this point in real life, I would just go over positive x and then down negative y. So our cosine here would be positive, because cosine's x, and our sine values would be negative in quadrant 4. So they might ask you that question. They say, if we plot a point in quadrant 3, what do you know about sine and cosine? You would say they're both negative values, aren't they? Quadrant 3, just think about it. Okay, here we go. So it says, find the exact value of the sine cosine and then also find the decimal. So notice on 43, we can find sine and cosine very quickly using our unit circle instead of having to draw a triangle. So it gives us, what's the sine and cosine of 90 degrees? So let's locate 90 degrees. Isn't this 90 degrees? So then my cosine at 90 degrees is 0. So this is how you'd write it. Cosine of 90 degrees will be equal to 0. That's true, right? Cosine at 90 degrees is 0. Everybody understand? And then our sine, you need to write it like this. Our sine at 90 degrees equals, sine of 90 is 1. You need to write it like this, otherwise people get confused. Because if I say to you, if I just show you this, what's the cosine of 90? You know I just go to 90 and say it's 0. You all get it. That easy. Now it says also find the exact value. Watch. You can even check that we're right. Type into your calculator. Make sure your calculator is in with this one, we're going to want it in, our answers are coming out radians. These are considered radians. Actually, put it in degree mode. Okay, ready? Type in cosine of 90 degrees. Hit enter. They both work. Yeah, they should work. You hit mode, and then go down to degree mode. Okay, here we go. Let's do this one. It says find the exact value. So now here's the thing, guys. In this one, we're trying to find the exact value of negative 240 degrees. So it shows us that. Well, to me, the unit circle is all positive degrees, correct? So instead, I like to figure out, instead of having to figure out where's negative 270, I'd rather just use this angle from here to here, because won't that be the same angle? The coterminal angle. Won't that be easier to do that and make sure we get it correct? So we are going to find the coterminal angle. Instead of looking at the negative, let's look at the positive angle. So we would take negative 240 degrees plus 360 degrees. So what angle are we actually evaluating here? 120 degrees. To me, it's always easier to evaluate a positive angle because that's what my unit circle gives me. And I don't have to think so hard. So everybody, we're using 120 degrees. Isn't that going to be the same spot as negative 270? Yeah, think about it, guys. Look, where's positive 270? Right here. No, wait. 240. Okay. Positive 240 is over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tick marks, correct? So going in the negative direction, that'd be down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Do you see how we're using 120 instead to make it easier on ourselves, not having to think about it so hard? Cool. So we are going to write, though, cosine of negative 240 equals cosine. We're looking at this value, so cosine is x, right? So cosine of negative 240 degrees will be negative a half. And sine of negative 240 degrees will be, sine is y, root 3 over 2. That is an exact answer, whereas your calculator can only give you a decimal answer. So, watch, type it into your calculator. Cosine of negative 240 degrees, hit enter. What do we get? Negative 0.5, isn't that what we got here? But we just put the exact answer. Everybody, do you see how the unit circle is helpful? So negative 0.5. Because it said in the instructions to then find the decimal. So you can type in sine of negative 240 into your calculator. What do you get? .866, so 0.87. Now let's check it. I want you to also type in square root of 3 divided by 2. See if it came out right, if we did it right. Square root of 3 divided by 2. Isn't that also 0.87? Yes. So this is giving us an exact answer. So that's why the unit circle is useful. Because your calculator can only give you approximate answers. Okay, let's do 46. It says find the exact value of sine and cosine. So look at 46. It's 45 degrees, positive 45 degrees. So that's where we're looking. So you would say cosine of 45 degrees will be equal to our x value. So root 2 over 2. And we're done. And it wants the decimal answer too, so you can just type it in. And we're also finding the sine of 45 degrees, which is our y value. Sine is y, so we also get root 2 over 2. So the unit circle allows us to give exact answers rather than decimals. Now, look, to find sine and cosine of 720, I'm going to have to really think hard. Like, I'm going to have to go around 360 and then figure out where the heck it ends up. Why don't we just make it easier on ourselves and get the coterminal angle so we can just use our unit circle and not have to think so hard. So let's take 720 minus 360 degrees. 360 degrees. So we're really just looking right here. Isn't this 360 degrees? Okay, so now it's easy. So we would say the cosine, we are going to put in the original angle. So the cosine of 720 degrees equals our x value, which is 1. And our sine of 720 degrees equals 0. And we're done. So it gives you a way to find these values very quickly. Okay, so look at number 19. It says evaluate. Now notice, yeah, I want you to type it into your calculator. Sine of 420 degrees. Go, 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 everybody. You get a decimal. Well, we would not accept that because this is a special angle on our unit circle. Well, I don't know that without actually figuring this out because look, isn't this 0 to 360? So instead of evaluating sine of 420 degrees, let's find the coterminal angle because it's not in the same spot, everybody. So 420 degrees minus 360 degrees. It's 60? 60 degrees. So we're actually evaluating what's the sine of 60 degrees. Well, that's easy. We know that the sine of 60 degrees is root 3 over 2. You see how easy that was, everybody? So your answer is root 3 over 2. So it allows us to give these answers really quickly and not even having to think. Well, because we have to use the unit circle. We have to give an exact value. We could use 420, but then we'd have to figure out where that is. That's 360, right? Plus, we need to get to 420. So you see how this just takes more thought process? That would put me there at 60 degrees. So wasn't it just easier to use 360? We use the coterminal angle, because remember, coterminal angle falls in the same spot. So the sine and cosine will be the same at 420 and 60. Well, we're answering the question. Sine of 420 is root 3 over 2. Our answer is root 3 over 2. Does that make sense? The answer is root 3 over 2. It said, what's the sine of 420? It's root 3 over 2. Where the other one said, does that make sense? Okay, let's do this one. So the cosine of 270, our answer is, go to 270. Cosine is x. So our answer is 0, guys. Are we confused? Are we paying attention? Are we lost? What's going on? Oh, it's not? So that's why we're confused? 26, thank you. So cosine of 270, I go to 270, that's right there, and our answer is 0. The unit circle makes our life easy. Okay, that's it. Go for it. Finish the worksheet. You should be able to finish and check that off with me before the end of the hour.